Hello, welcome back to Mr. Class. We are still in chapter 1.2, more concept, but in this video, you need to focus on concentration measurements. Objective that you need to achieve in this video is you need to define these concentration measurements and then you are going to do the calculation. For example, the question may give you percentage by mass and then ask you to determine the molarity. So basically, this is a new concept for you, so you need to pay more attention in this video. Okay, before go in details into each definition of concentration measurement, you need to know how to differentiate among solute, solvent, and also solution. Basically, solute in bahasa we call zat terlarut, and then solvent is penlarut, and the solution is larutan. For example, the Milo that you drink is solution, while the Milo powder is solute and the water is solvent. Okay, so how about solute, solvent, and solution for the Ribena that you drink? Yes, definitely, you are right. The Ribena that you bought from the supermarket is the solute, water is solvent, and then the Ribena that you drink is solution. So do keep in mind that solute not necessarily solid. Molarity is a common concentration measurement that you used before, which is defined as mole of solute dissolved in 1 liter of solution. And I believe most of you just remember mole over volume. Okay, but you need to include the term solute and also solution in all the concentration measurements that you learn today so that you will not confuse when you want to answer tutorial question later. So in this case, I want to emphasize again, besides from remember the definition for molarity is mole of solute over volume of solution, and then the unit of volume must be in the liter. So do keep in mind that 1 decimeter cube actually is equal to 1 liter, while 1 centimeter cube is equal to 1 ml. Okay, so 1 liter is equal to 1000 ml. So repeat again, molarity is number of mole of solute over volume of solution in liter. Okay, let's look at one example here. Basically, if we look at the question is asked us to look for the molarity. So just now we already learned the definition. It's mole of solute over volume of solution in the unit of liter. Okay, let's read the question. Matriculation student prepare a solution by dissolving 0.586 gram of sodium carbonate in 250 centimeter cube of water. So from here we know that the mass can help us to determine the number of mole. Even this question doesn't give us the number of mole. Okay, so number of mole of sodium carbonate is calculated. Okay, then the question also given us the volume, but this volume cannot substitute directly into the formula because the volume is in the unit of centimeter cube. So we need to convert the unit centimeter cube into the liter. Then next only we substitute into the formula, then we can get the molarity of the sodium carbonate is 0.0221 mole per liter. Okay, now we look at the second concentration measurement, which is molarity. Where if you notice the spelling, the difference of the spelling is the R replaced by the L. Okay, then now look at the definition. Mole of solute looks like similar with the molarity that we discussed just now, dissolved in 1 kilogram of solvent. So just now is volume of solution. This time molarity is mole of solute over mass of solvent in kilogram. And then the symbol for this molarity is small m, while the symbol for molarity is capital M. Now let's look at example number 2. Calculate the molarity. So when you read the question, we can start to recall. The formula for this molarity is mole solute over mass solvent in kilogram. Okay, containing 8.4 gram of ethylene glycol in 200 gram of water. The molar mass of ethylene glycol is 62 gram. Okay, so we have mass and then we have molar mass. So these two information can help us to determine number of mole. So the number of mole is 0.1355 mole. And then, so we settle for mole solute. Second, we need to look for the mass of solvent. So in this question, they already mentioned that they will dissolve in 200 gram of water. But we cannot substitute directly 200 gram into the formula because the formula say that the mass of solvent have to express in kilogram. So now you need to convert 200 gram to 2 kilogram, so which is 0.2 kilogram. Then substitute the mole of solute and mass of solvent into the formula, so you will get 0.6775 mole per kilogram, or you can simplify with the unit small m. The third concentration measurement that we going to learn is mole fraction. Fraction in bahasa is pecahan. So as like the name, you need to calculate the number of mole for each of the substance that in the solution. For example, if the solution is made up from solute A and solvent, so you need to calculate the mole of solute A and also the mole of solvent. So the symbol for mole fraction is X, while mole fraction has no unit. Now let's look at the simplified symbol for the formula of mole fraction. Mole fraction of A equal to number of mole of A divided by the total number of mole in the solution, which in this case is mole of A and mole of solvent, which is water. Okay, do keep in mind that mole fraction always less than 1, while total mole fraction is always equal to 1. Now let's look at the question here. A solution is made up from 16 gram of calcium chloride and also 64 gram of water. And then they give us the density of the solution is 1.18 gram per mole. So this question asks us to determine mole fraction of calcium chloride in the solution. And next they ask us to calculate the molarity. So based on the three information given here, we need to determine mole fraction and also molarity. So that is why it is important you need to remember the definition of each concentration measurement. If you have no idea what is the definition, means that you will not able to write out the formula and then you cannot continue to do the calculation. Okay, so like just now we say, based on the terms mole fraction, we already have idea that we need to find out mole of water and also mole of calcium chloride, which respectively 0.1441 for calcium chloride and 3.5556 for water. Okay, here please do the remark, always keep your answer in 4 decimal places. Okay, then now we can determine the mole fraction of calcium chloride in solution. 0.1441 divided by the total number of mole equal to 0.03895. Why just now we say mole fraction have no unit? Because when you look at here, this is the mole and mole can be cancelled out. So that's why there is no unit for mole fraction. Okay, now we look at the second part of the question. The question is asking us to look for the molarity. So the formula for the molarity is mole of solute. So in this case is calcium chloride over volume of solution in liter. So mole of solute, just now we already do the calculation. So no need to repeat at this step, actually is okay. Okay, then next one we need to look for the volume. But based on this question here, we are only given the mass. We are not given the volume. Okay, but we know we can determine the volume based on the density. Do keep in mind, volume of solution does not equal to mass of solution, except the density of solution is 1 gram per mole. So in this case, it is not 1 gram per mole, and then you cannot assume it is water because they already given us the density of solution. So with the mass that given in the question, we total up the mass of solution is 80 gram, and then we use the formula of density, then we able to looking at the determine the volume of solution. So because the unit given here is gram per mole, so the volume that you calculate also will be the unit of milliliter. But based on the formula, we need to substitute the volume in the unit of liter, so you have to do the conversion. So again, the want to emphasize and let you know that the definition for each concentration measurement is very important. Okay, after we get the volume and then we have the number of mole of solute and volume of solution, just substitute in into the formula and then we can able to get the molarity is 2.2156 mole per liter, or you can just substitute the mole per liter with the capital M. In this slide, we are focused on percentage by mass, at where it is the ratio, also can be meaning of the fraction. Okay, for the mass of solute to the mass of solution, and then multiply by 100%. So generally, this is the formula, and then the symbol for percentage by mass is this. Okay, let's look at example 4. A sample of 0.892 potassium chloride dissolved in 54.3 grams of water. Calculate the percentage by mass of KCl, potassium chloride. So it means that you have to put the mass of potassium chloride on the top here and then over with the total mass of the solution. So in this case, it's 1.62%. So to keep in mind, the unit for the mass must be similar. Let's say gram and gram. So let's say in the question they give one is in gram, one is in kilogram. So you have to do conversion unit so that both of the unit of the mass are similar. Okay, the last concentration unit is percentage by volume, where it is a bit different from the previous one, just in the measurement dimension. So for percentage by mass is the mass, while percentage by volume is using the volume. So volume of solute to the volume of solution and then multiply by 100%. This is the formula for percentage by volume, and this is the symbol for the percentage by volume. Okay, let's look at example 5. 200 ml of perfume contain 28 ml of alcohol. Calculate percentage of volume of alcohol in this solution. So volume of alcohol in this solution, so this is the formula. So 28 ml over 200 ml times with 100%, so we get 14%. So again, reminder, unit volume for both must be same. If different unit are given, means that you have to do conversion, yeah? Beside the 5 concentration measurement that we went through just now, you also need to remember the formula for the density of solution. So I think this is not a problem. Okay, why? Because if in question number, example 3 just now, you already can see sometimes in the question of about the concentration measurement, density of solution will be involved to help us to either determine the mass or the volume of the solution. So means that altogether you have 6 formula to remember 5 concentration measurement and also density of the solution. Okay, do keep in mind that sometimes the question can give us density of solute or density of solvent. So no matter if density of solute or density of solvent, just make sure here is still mass. But if density of solute given, means that here will be mass of solute. Okay, and then here will be volume of solute. Question in this example is similar with example 3. Only the concentration measurement required to determine are different. For example, in this example, they ask us to determine percentage by mass. And another one is molarity. Okay, so this question actually would like to emphasize for you that the formula for each concentration measurement is important. So because in the question they will not give us the formula, so if you cannot remember the formula, then you are not able to continue to answer the question. Okay, so first we have to list down the percentage by mass. Formula is mass of calcium chloride 16 gram over the mass of solution at where contains 64 gram of water. So when we substitute in, we can get 20%. So the next one is molarity, number of mole of solute over mass of solvent. In this question, mole of solute is not given, so we have to find number of mole for solute, which is CaCl2, calcium chloride, and then we substitute this value into the number of mole of solute. Mass of solvent given in the question is in gram, so we have to convert to kilogram. So after convert, we will get 0.064, and then the final answer is 2.12 molar. Now let's look at example 7. In this question, they given us 37.8% by mass of HCl, and then they also given us 1.19 gram per ml, which is the density of solution. Okay, then they ask us to calculate the molarity. So as usual, the first step we need to write down the formula for the molarity. So it's mole of solute over volume of solution in the unit of liter. So when we look at this question, we are not able to identify number of mole of solute. So in this case, we need to do assumption. Okay, we assume there is 100 gram of solution because of the percentage by mass given is 37.8%. So means that in 100 gram of solution, they will contain 37.8 gram of HCl. So and then with the mass of HCl divide with the molar mass of HCl, we able to identify the number of mole of HCl. So next is the volume of solution. So again, from the question here, we have no volume of solution given directly, but we will have the idea that we're able to find the volume of solution using the density. So now we have to list down the formula for the density. Given is 1.19. Mass of solution, because just now I assume there is 100 gram of solution, so that's why mass of solution is 100 gram. Volume of solution is unknown, so then we calculate the volume of solution, which the unit is in milliliter, but then refer to the formula, the unit of volume must be in liter. So we convert the milliliter into liter, and then now we can substitute the value of number of mole and also volume of solution in liter into the formula. So this is the final answer. After discuss the example, now let's proceed to the tutorial question number 9. You are given the 10.5 molar NaOH solution contain the density of the solution is 1.33 gram per ml. And then this question is asking us to determine the mole fraction of NaOH. So as we always know, actually in this topic, the first thing that we have to always remember is the formula of concentration measurement. Okay, so the 5 concentration measurements you have to remember. Okay, so first we need to list down the formula that require mole fraction of NaOH is equal to mole of NaOH over total number of mole of NaOH and water. This is because solution always make up from solute and solvent. Okay, so solvent is water while solute is NaOH. Second, when we look, we have to determine number of mole of NaOH and also water based on the formula above here. However, in the question above here, we are not given the number of mole NaOH and number of mole of water directly. However, we know that we can determine the number of mole of water and NaOH indirectly from the molarity. Therefore, we have to do assumption. Assume there is. Okay, so assume there is 10.5 molar solution. Okay, so when we do this, we consider we already do the assumption. Okay, what does this mean? If we have 10.5 molar solution, means that in 1 kilogram of water, there is 10.5 gram more of NaOH. So from the 1 kilogram of water, it is equal to 1000 gram. So we divide by the molar mass of water, we will get mole of water is 55.55 mole. So now from here, we already have the number of mole of NaOH and we also have number of mole of water. So last step, we can substitute the value into the formula and the final answer for the mole fraction of NaOH is 0.159. So again, reminder, always remember formula of concentration measurement. Okay, second part of the question number 9 is I ask us to identify the percentage by mass of NaOH. So as usual, you need to list down the formula, which is mass of solute, in this case is NaOH, and mass of solution, in this case is NaOH and water, multiply with 100%. Second, we have to determine the mass of NaOH and water. Okay, when we based on the information given 10.5 molar and 1.33 gram per mil, we are not able to obtain or get the mass of NaOH and water directly. So means that we have to do assumption. But this is the second part of the question number 9. So we no need to do assumption. Do keep in mind that we only assume once. Okay, this is important. Always assume once only. So just now we already assumed that is 10.5 molar solution, means there is 10.5 mole of NaOH in 1 kilogram of water. At where we know 1 kilogram of water represent 1000 gram of water. So with the with the mole of NaOH, we multiply with the molar mass, then we able to get mass of NaOH in unit of gram. This is why we change 1 kilogram into 1000 gram. Okay, we want to make sure the unit is similar when we want to substitute into the formula. Okay, so this is the final answer. The percentage is 29.6%. Okay, now let's look at the third part of question number 9, at where the question asks you to identify the molarity of the solution. So as usual, first step you have to list down the formula. So which is mole of solute over volume of solution in liter. In this case, solute is NaOH, while solution is NaOH solution. Step number 2, we need to determine the volume of NaOH based on the formula of density. Okay, so mass of solution is already identified in question part 2, which is 1420 gram, while density given in the question is 1.33 gram per mil. Okay, so substitute the value in, then you will get the volume basically is in milliliter. But because we know in the formula, they request the volume of solution in liter. So we convert it to liter. Step number 3, we substitute the value into the formula. So mole is 10.5 mole because just now we at the first part of the question, we already assumed there is 10.5 mole of NaOH in 1 kilogram of water. So then volume is what we calculate, 1.07 liter. Press the calculator, we get 9.81 mole per liter. Now we are in question 10. The density of the solution is 20% by mass, and density is 1.6 gram per mil. First, they ask us to calculate the molarity. So again, you see, we need to list down the formula. Molarity is mole of solute. In this case, is KCl, while solution is KCl solution. So again, when we look at the question, you are not given number of mole KCl and also volume of KCl solution directly. So means that step number 2, we need to find out mole of solute and also volume of KCl solution. So because of the information is not given directly, means that we need to do assumption. Okay, so assume there is 100 gram of solution. Why we assume 100 gram of solution? Because in the question here they give us 20% by mass of KCl solution. So it will be easier. We assume 100 gram of solution, means that there will 20 gram of KCl and 80 gram of water. With this, we have the mass of KCl, and then this mass of KCl able to help us to identify the mole of KCl by divide with the molar mass of KCl. So molar mass of KCl, you have to identify it yourself, yeah? Okay, second, we need to find out the volume of the solution. So volume of the solution, we will use the density of solution to help us to determine volume of solution. Okay, so by using the formula of density, we're able to determine volume of solution is 94.34 milliliter. Okay, step now, after we have the mole and the volume, then we can substitute the value into the formula. Okay, just remember in this case, based on the formula, the volume must be always in unit of liter. So even though you keep here as milliliter is okay, no problem. But when you substitute the value into the formula, make sure you already convert it to liter. After that, you press the calculator. This is the final answer for the molarity. Okay, so to keep in mind, just reminder again, always remember the formula for each concentration measurement. Second, we only assume once. Okay, so you will see later, question number 10, we have part 2 and part 3. We will not do assumption anymore. Okay, because we already do assumption in the part 1. Okay, next one is always keep the answer in 4 decimal places. Okay, except final answer. Okay, so you see here I keep 4 decimal place. Here I also have 4 significant figure lah. Okay. Part 2 of question 10. Question asks us to identify molarity. So as usual, first step, list down the formula. Is mole of solute over mass of solvent in kilogram. Solute again, HCl. Solvent is water. So because just now in part 1 we already do assumption, so we also already have the idea. The mass of KCl is 20 grams, so the number of mole is 0.2681, while the mass of water will be 80 grams. So if we convert to kilogram, it is 0.08 kilogram. Then we will substitute the value into the formula. So we will get 3.36 mole per kilogram. Third part of the question, we are going to look for the mole fraction of KCl. So again, list down the formula. This time mole fraction is mole of KCl over total mole of KCl and water. So again, in part 1 and part 2, we already determined the mole of KCl. So in this step, we need to determine the mole of water, which is 80 gram divided by 18. So we will get 4.444 mole. And then step number 3, substitute the value into the formula, and then the final answer that we get is 0.057. Okay, now we continue with question 11. Density of the solution is 1.84 gram per ml, while the percentage by mass of the solution is 95%. And then now this question is asking us to identify molarity. So as usual, step number 1, list down the formula for the molarity, which is mole of H2SO4 over volume of H2SO4 solution in liter. So basically, when we look at the question, number of mole and volume of solution cannot be calculated or identified directly from the question. Hence, assumption is needed. Okay, so you are going to solve this part 1 yourself. So now I'm going to discuss question number part 2 with you. What is the volume of acid needed to prepare 1 liter of 0.08 molar solution? So if we refer to the part 1, the answer of part 1, 17.9. Then now you want to use this sulfuric acid solution to prepare another one with the concentration of 0.08. So from this process here, we know this one is a dilution process. So if this is the dilution process, so means that we are going to use the formula M1V1 equal to M2V2, because we know that part of the H2SO4, concentrated H2SO4, okay, this is 0.08 molar of 1 liter sulfuric solution. And then how many of the acid? Okay, so you just need to add a small amount of the concentrated sulfuric acid, okay, into a container. Then you will add up the water up to 1 liter so that you will get 0.08 molar. So at where in this case we have to get the idea that number of mole of sulfuric acid remain. That's why we can use formula M1V1 equal to M2V2. M1, let's say you calculate part A already, so it's 17.9. V1 is the one that we want to find out how many acid is needed. M2 is this one, 0.08, while V2 will be 1 liter. Okay, so press the calculator, you will get 4.47 exponent negative 3 liter. Okay, but normally in the lab, the apparatus that we use normally will be measured in milliliter. So it is more logic if we convert the unit to 4.47 milliliter. Okay, now we continue with the last question in tutorial. A sample of 0.4 gram anhydrous NaOH was dissolved in water and make up to 100 ml solution. Okay. Then 25 ml of the solution was then neutralized with dilute H2SO4. So basically we get the idea first. You will have first part of the question mentioned that you will have 100 ml NaOH solution, okay, and then you only take out 25 ml and then react with another solution which is sulfuric acid. Okay, so now we try to solve the part 1 first. Find the molarity of the solution. So the formula for molarity is mole NaOH over volume NaOH solution in liter. Okay, so in this question we have mass. So if we divide the mass of NaOH with the molar mass, we able to find number of mole of NaOH. Volume of solution also given. We only need to convert to liter. Then we able to determine the molarity. So in this question, part 1, assumption is not needed. Okay, no assume is needed for part 1. Okay, so now we proceed to part 2. Part 2, the question is asked us how many mole of H2SO4 will react with required for the neutralization. So because of this is a chemical reaction, basically we are going to write out the chemical equation. NaOH react with sulfuric acid is a neutralization process, so we'll produce salt and water. Okay, then we need to balance the equation. 2 more NaOH react with 1 more sulfuric acid, produce 1 more sodium sulfate and 2 more of water. Okay, then we are going to use from equation 2 more NaOH will react with 1 more sulfuric acid. Okay, so means that from here you already have number of mole of NaOH. Okay, which you calculate this one is 0.4 gram and then already make up from to 100 ml. But when you react with the sulfuric acid, actually we only use 25 ml. So we can use the formula. So we need to find out the number of mole that react with sulfuric acid. Okay, and here we already know the concentration. Okay, we have the volume, then we can use formula mv over 1000 to identify the number of mole of NaOH that react with sulfuric acid. Okay, so after, let's say, this number of mole, you are going to substitute in this part. Okay, then you can determine the mole of sulfuric acid that will be produced. Okay, so that's all for this question. Please try out yourself and then we will discuss more if you have any question during the tutorial class. You can check out following 2 videos. First video will guide you how to differentiate solute, solvent and solution in the question. And second video will show you the calculation step in solving the concentration measurement questions. Thank you for watching this video.